Lisa, could you get us started? Yes, all right. So welcome to the Carbon Equity webinar on unleashing the power of AI for climate technology. We have a couple of wonderful guests who I will introduce in a bit, who will be talking us through what is happening within all the different AI applications for climate technology, but also what is the investor point of view, how to think about investing in climate technology, and what is legit and what is a bubble in terms of climate investing. As mentioned, feel free to introduce yourself, writing your name and role in the chat. Always interesting to see who's around. For any questions that you might have, kindly put them in the Q&A section. So there's a Q&A section at the top or the bottom of your screen. And we will be monitoring those questions and asking these questions throughout, and of course, also at the end of the webinar. All right, then what we're going to be talking about, I'll give a very brief introduction on myself and on the speakers in the room. I am joined today. My name is Jacqueline van den Ende. I'm one of the co-founders and the CEO of Carbon Equity. And I'm joined here by Lisa Rubinstein. I'm not sure if you can see her in the view. Lisa, could you briefly introduce yourself?
Yeah, hi there, everyone. I'm Lisa. I'm one of the other co-founders of Carbon Equity. I'm the head of impact. So I lead over our impact strategy, due diligence, and reporting communication.
Okay, excellent. Cool. And then we'll dive into the moat of this discussion on climate and AI and a Q&A section. So just to get started, a few words on what carbon equity is for people who have not encountered carbon equity before. Carbon equity is a climate venture capital and private equity fund investing platform that enables you to invest in some of the world's best climate funds and therefore in some of the coolest climate technologies, including artificial intelligence applications to help solve climate change issues. And at Carbon Equity, you invest from low minimums in top climate VC and private equity funds, which allows you to invest with some of the world's best investors, such as hopefully Juan in the future. All right, let's dive into the topic. So we're going to be talking about climate and artificial intelligence, and how can artificial intelligence help us solve some of the biggest challenges of our time. I tried it myself. I asked ChatGPT how to solve climate change. It gave me a couple of suggestions. We should obviously start mitigating greenhouse gases. We should decarbonize our industries, and we should promote renewable energy. I thought that was still pretty high level. So I asked ChatGPT, what is like the top priority? What's the number one thing we should do? According to ChatGPT, the number one thing is we should reduce fossil fuels, of course. And then I asked ChatGPT how I could convince Wael Sawan, the new CEO of Shell, on why, from a business point of view, he should be cutting back on fossil fuels. And it gave me a load of arguments focused primarily on stranded assets and also declining social capital of Shell, which I thought was a pretty good argument to convince the CEO of Shell to finally start getting serious about energy transition. So we had an interesting chat. Did unfortunately not yet solve climate change through ChatGPT, but we're working on it. But AI obviously can mean a ton for climate change. AI is capable of enhancing, supercharging data analysis and can dramatically improve the effectivity of software and hardware solutions for climate change. It can help us analyze huge data sets in a much shorter period of time, leverage pattern recognition to build predictive models, for example, of extreme weather. I listened to a podcast with NVIDIA, who are developing super chips super chips, who can much faster and at much higher level of precision predict extreme weather events with much higher energy efficiency. So there are tons of applications here that are super interesting, and where AI can helpfully accelerate our climate mitigation, but also adaptation efforts. So we are joined by two really awesome speakers to discuss the opportunities, potentially also risks of AI and climate technology. We are joined by Bastiaan van der Rakt. He is Dutch, and he has spent over 20 years as an entrepreneur working in machine learning and data science. He is the CEO and the CTO of not one, not two, not three, but 4 different tech companies. He's an advisor, he's an investor, also an angel investor, also as an angel investor. And he is a co-founder currently and the CEO of a company called Deploy. And Deploy, we'll talk more about it, but makes AI models explainable and replicable. So trying to mitigate the big black box effect of artificial intelligence and making our models more safe through replicability. Then we are joined by Juan Moldun. Juan is a partner at Energize Ventures. He's been a partner since 2016. And Juan previously worked with JP Morgan. He has an MBA from the University of Chicago. I guess you did not yet learn about artificial intelligence in Chicago back then. But Energize Ventures is a climate software investor and has invested in many AI-powered climate software companies. So it'd be super interesting to get your view on all of the things that you're seeing out there. All right, so let's dive right in. We'll talk about this later. Cool. So, Bastiaan, I think legitimately call you the OG of artificial intelligence, at least in the Netherlands. AI sort of seemingly came out of nowhere in the past year with ChatGPT taking over the world, quite literally. But how did you end up working in AI or working with AI over the past decades, long before it was a well-known thing?
Thank you, Jacqueline. I feel a bit uncomfortable and old now, but it slowly moves. So it was like I tend to get more and more in. So I studied more system engineering, had a company who made first analysis on logistics in healthcare or in port logistics. It's basically system engineering, simulation, multi-agent systems, which has something to do with AI, but not a lot. And then you need 3 things. It's data, it's the modeling itself, and infrastructure. It started that more and more data was coming in those bigger companies. So they needed better models. And in the end, they need better infrastructure. And now the last 2 companies, which are Deploy and Engines. So Engines is focusing on what you call now machine learning operations. So more on the model and the infrastructure is getting more important. And also Deploy is focusing on the infrastructure to get that model in an explainable way and what we call human-centric design. So the human has to be in the loop. So AI is about multiple things. So it goes from data to more modeling to more the infra behind this whole big system of AI.
And Bastiaan, for the novices in terms of AI, when you talk about the infrastructure of AI, what do you mean?
Yeah, so it's all semantics and terminology. So when I think about AI, it's like which can perform a human-like intelligence. And then within that, we have machine learning. So I think a good example of machine learning that we all know is your email spam classification. So it starts with an algorithm which is generally used, but you will say, okay, but this is not spam or in your inbox, or the other way around. Okay, it ended up in my spam box, so I have to put it back to my inbox. And then that machine is learning for you personally what it is. So that's actually machine learning. Yeah. So you go from there. And if that model enlarges and gets more data and needs more modeling power, then you need to build more persistent infrastructure.
Cool. All right, we'll talk more about it in a bit.
Yeah.
Juan, did you have a background when you started in artificial intelligence, when you started working as a partner at Energize Ventures?
I did not, actually. My background was always around the financial side. So I'm primarily an investor. A technologist, obviously, at heart, but what we're focused on is making really good investments at the end of the day. Energize focuses at the intersection of software and climate, or software and the energy transition. And we've been covering that space for a very long time. From the very inception of the firm, our view was that the energy transition was going to be really driven by decarbonization, obviously, more distributed assets, and these distributed assets tended to be more connected. So there was more data flowing through them. They were more digital in nature. And so at the very kernel of our thesis was this idea that software could help us make better decisions. It can help us manage assets better and operate these systems more efficiently. And so data analytics, sort of at its core, has been a part of our thesis from the very beginning. But we've always approached technology more from the lens of, are we not just developing technology for its own sake and getting really technical with it, but are we actually solving industry pain points? Are we actually solving something that these engineers, these asset owners, these developers will buy? Because, and Bastian is shaking his head, it's easy to get lost down the rabbit hole of making technology perfect, or trying to find the most complicated problem to solve. I think AI is a really exciting toolkit, but at the end of the day, it's a toolkit. It's a tool in the toolbox. How can we use that tool effectively to actually drive some sort of change, some sort of impact, some sort of real return on that investment?
And Juan, just one quick personal question, because coming into the space, and I imagine now you're starting to see within the broader ecosystem of software applications for climate change, more and more AI applications. How do you get on top of this? Because artificial intelligence is pretty technical. The universe of opportunities of things that you can do with it is immense. Suddenly everything is an AI company. How do you educate yourself on artificial intelligence? What are you reading? What courses are you doing? How do you get started?
That's a great question. Fortunately, I think that the climate community is very open and very embracing. And I think at the end of the day, everybody's still sort of learning, right? We at Energize are very close to the ultimate customers that these technologies are actually touching. So we can help sort of our team and sometimes even the entrepreneurs be educated by the problems that are actually needing to be solved, right? So we are big believers that technology isn't pushed onto the space, but rather pulled by the buyer that actually has a problem. And so, that helps a lot. It helps a lot to be able to understand the customer. Sometimes it's more important to understand the customer than maybe the code itself, right?
I love that. I read a blog yesterday that said too many entrepreneurs focus on building a product, but not on what you need is not a problem. You need a customer who has a problem. That's the main thing.
That's right.
Yeah. I saw in 15 years a lot of really great AI modeling or machine learning modeling ending up on a computer doing nothing, basically. And there were big projects or large firms because they wanted to do something with AI. They didn't want to solve a problem.
Yeah, exactly.
No, I think the other element of that, if I can maybe just add to it, is you have to have an immense amount of curiosity, right? Because if you're able to kind of follow the thread of, okay, here's a problem and here's a technology that might be able to help solve it, how, why, right? That's what is pretty exciting about my work, is that we get to see the technology as it's coming up, and we get to see those real use cases. But you have to be willing to ask those questions and be willing to learn.
Yeah, absolutely.
I think both really worth exploring. I think before we dive into the use cases, Bastian, could you walk us through what types of AI do we have? Is machine learning a type of AI for you, and what other types are there?
Yeah, I tried to get in there a little bit in the previous question. So I think AI is used to perform any task which is human-like intelligence. So I use human-like, because it looks like a human, but it isn't. Machine learning, like the email spam classification, I think that's a really good example of a machine learning learning your stuff. You get that. We all do that, and it's helpful. And then you get all kinds of new algorithms or packages which is coming up. So probably you heard the term deep learning algorithm. So basically that is like a lot of libraries of a lot of image to determine if you can pick an apple, if it's ripe, you can harvest it. And it's deep learning because it evolves even more stuff than we can imagine. So I don't have, even if I pick apples for a while, I don't have a million pictures of ripe or non-ripe apples in my head. And this algorithm, this deep learning algorithm, can even see on the picture what is the sugar rate in that apple, etc. So it can have a lot of parameters more than we can see with the human eye, or we can keep track of. As a human, we can do 6 or 7 variables. Well, in that apple imaging example, I don't know, are millions, of course. So I think that's the term deep learning. And then we all talk about ChatGPT, which is basically a combination of language processing and a lot of different things. Probably we'll get to that later. But there are different types of streams within AI. And now comes the big thing. We are all mixing them up. And that's because we tend to have innovation, and then it's for a certain domain or for a certain problem. But then we see, okay, well, we can use that same technique and build it on top. So you get meta models or ensemble modeling or multi-model AI, etc. Yes. So it's really hard to keep up, even for me. But in essence, you use the data, you make a model, and you have some infrastructure, and you need some human feedback loop, because we still have to understand what we are doing. That's also where we are a little bit in doubt now at the moment.
Yeah, fascinating. I think we have to talk about ChatGPT for a second, because everybody's talking about it, but love to hear your view on what do you think it's amazing at, and what do you think it's not well suited for?
Yeah, that's a really good question. So I think if you if it helps you with repetitive tasks and things you can check yourself, it's okay. It probably helps you. But if you're not able to at least tend to have a form of a benchmark, so check it, then it could be that you're misusing it. So you're the result of ChatGPT. You're not sure if you're using it appropriately to do the things that you want to use it for. And it's ever changing, but it's really helpful. And I think a lot of things you can benchmark. Even with the coming up, we have ChatGPT, we have multiple different large language models at the moment. So you can easily, what I do, I just throw it in at multiple things, and you get like multiple answers. And even that gives you some insight or some benchmark. That's actually what we always do if we try to learn something new. We try to do it at multiple, we ask multiple opinions. So it's not that scary, but well, you could misuse it. It could be a bias. Of course, it's used for fake news, etc. So you have to be really careful. If you cannot explain it yourself, or if you ask like 2 or 3 other opinions and you're still in doubt, then probably it's not okay.
Yeah, exactly. So one day we're going to get a super aggregator of all of these different AI models, which will give you an aggregated answer of all the different models.
Yeah, we just still need to know what the answer is about. So we all know that the Douglas Adams Hitchhiker's Guide to the Galaxy. So the answer is 42. Yeah, 42 what? So if you cannot know what the answer is about, then it's useless. So again, I think Juan is right. So which problem do you want to solve? So there are only ill-structured problems. So you need to have the right solution for the problem. So if you have like a meta model of 1 million ChatGPTs, and the answer, you cannot see or overrule the answer or explain the answer, then
Can I maybe add something to that? I think that
sure.
there's a level of creativity that you have to think about in terms of how do you use these things, right? I'll give you an example. We work with a company that does workflow automation for financial processes. So basically to think about financing any type of renewable development. Project finance is really complicated, right? You have all these legal issues, you have very many, complex clauses, complex accounting, just complexity in general, right? They figured out that many of their customers were having to submit RFPs for grants, right? For especially for new sort of new debt structures in the United States. We've just passed the Infrastructure Reduction Act, which has made capital very widely available. But if you've ever written an RFP, that's sort of a tedious, complex, sort of kind of task, right? Well,
I agree.
they have figured out
request for proposal, that's
request for proposals,
Yeah.
and for a grant, right?
Yeah.
And so what they figured out is, well, they already have in their platform lots of context about the project itself, right? They have all the financial data, they have the legal data, they have the location, they have the developer, they have all the important pieces that you might want to include in this request for proposal. And they figured out that they could plug into a language generation tool to help their customer be able to produce these text, RFPs in a fraction of time that it would have otherwise taken. Why is that a good idea? Well, obviously it helps, reduce significant amounts of time in a task that is fairly easily controlled, and they're able to take into that process context specific data about that particular project or that particular, bit that they're trying to solve. So to add to your point, Bastian, it can be easily checked, right? Like this is accurate or not accurate. And you're able to basically create this voluminous text that is actually very useful.
Yeah.
Yeah, so this is a really good example because there's a clear framework. You can test it, you can check it. Maybe the auditors of all those incoming RFPs are not happy anymore because we get a lot of applications. We see that already in grants and stuff because it's really easy to write an application. But this is like a really, repetitive problem that you're solving, and you can check it. So good to go.
Let's talk about the solutions, because what, Juan, are the most, interesting applications of AI that you're seeing specifically for either climate mitigation or adaptation purposes?
Yeah, I think that the two big categories that I would categorize in is, number one, tools that help with data and insights that lead to better outcomes for systems, and number two, the workflow examples that I've just mentioned, where automation can lead to a much more efficient or seamless process. Those are kind of the two big buckets, right? And if we kind of maybe dig into one or two of those examples, we have several companies that we've seen, and one that we've invested in called Jupiter Intelligence, that takes a vast amount of data around climate, around weather, and around terrain patterns and actual blueprints for specific assets, and is able to converge all of that data and make much more accurate, down to very physical location predictions about the risk that a particular asset actually has, maybe because of climate change. So they're incorporating AI, machine learning, a lot of deep learning actually, to automatically and continually improve this sort of dynamic climate risk modeling to reduce biases.
Who is a customer of such an application?
Yeah, the customers could be cities. So actually, imagine Amsterdam. What happens if that 100-year flood happens in 3 years? What does the city's infrastructure look like? What does the power generation assets look like? Which of the transformers might be at risk for being underwater, for example? So it's cities, it's asset owners, it's the financing counterparts to those assets. So think about the lenders, that have a lot of risk in their portfolio that they may not be considering. And it's insurance companies that, again, are underwriting potential risk. That probably don't understand they understand the severity, but they may not understand the likelihood of some of those outcomes.
Yeah, exactly.
Can I ask you a question? Does it also change the dialogue between, well, let's now say the city of Amsterdam and that reinsurance company? Because now the whole modeling and risk mitigation will be completely different because, well, it used to be like literally once every 100 years. So 1 divided by 100, and then there was a premium and the city of Amsterdam will pay something like that. Does it change that conversation?
Absolutely. And it changes where you're able to cite assets, and it changes what those assets will actually ultimately cost, right? So yeah, that's a really good example of data driving to different, potentially better, hopefully better outcomes, right? But that's one example. There's another, we've seen a lot of other examples within the renewable power generation, for example. So we have a company in our portfolio called Spark Cognition. This was one of the earliest forays that we had into the field of data analytics. But if you think about, those wind turbines, right? Just picture them in your mind. They have there's this massive equipment, right? At the nacelle, at the top of the wind turbine, there's, spinning equipment, right? Like the spins, and that's what actually generates the electricity.
Right,
That is giving a lot of data around vibrations, sound, temperature, the actual machine itself, right? They figured out that you could plug into that data system and be able to analyze micro patterns that the human might not really pick up, right? Might not really realize. And they're able to use that and train an engine to be able to predict when that turbine might fail, saving millions of dollars in downtime costs and obviously in repairs, right? If you're able to know, hey, this turbine is, spinning a little bit differently than the others, let's go ahead and repair that. So it makes the system as a whole potentially much more resilient.
Super fascinating.
Yeah, it's really fascinating.
That's I think an example that especially the data is completely detailed on every second, every level. That's changing now. Actually, the models, of course, are more sophisticated. We're already there for a while. So and the infrastructure, you can compute it, you can do it. So this is like data and infrastructure, which is improving, and the model is actually not making, of course, it's making difference, but not a big difference.
Yeah,
that's right.
We got a fascinating question from the audience. And let me just read it out loud. So they say, AI, we see many applications for incremental change, right? So optimizing all of these sorts of things that we were just talking about. Can either of you also share some examples of how AI is helping with changing the hardware of all the hardware that we need for the transition?
Yeah. Go ahead, Bastian. I could take a second step.
Hardware is not my specialization, but I will try to answer that. What you see is, of course, that so more my old field is that you can do much more simulation. So you can use AI and all kinds of modeling. Well, the example of the wind turbine, you can make 3D visualizations of the whole world where you're testing a new wind turbine or something. So for hardware, if it's a chip or a wind turbine or maybe a moving vehicle, you can create a whole world with all like virtual cars or virtual things to check if it's still in line. This is not new. So when I was studying in Delft, we had the automated guided vehicles, would cost €1 million or something. We couldn't make 250 of them. We make 2, and the other 240 were virtual. And there were collisions between a physical vehicle and a non-physical vehicle. So you could already test hardware back then. But that was like really early stage. But now you can, even the real nanotechnology chips, you can check. It's like it costs less and less money to make 1 million tests. So you can feel literally very, very fast in your early stage of your company.
Yeah.
Juan, in your view, are these simulations, does every company build their own software to do that? Or are there independent providers that help you run these simulations?
Yeah, not every company does this, right? There's a couple that we've seen that we'll work with, especially with the larger OEMs. But no, this isn't. In our experience, it's not that every company that's making hardware it has their own simulation software. There's a company, I'm trying to figure it out if I can maybe put it in the chats. There is. Let me just make sure I've got the right website here. Yeah, here we go. There's a company called AIonics. We're not investors in this company, but this is one that helps to basically accelerate the development cycle by running a bunch of different computations, running a bunch of different simulations. Here we go. Let me just put it in the chat. We've seen, similar kinds of companies that help with chip design. One of the most interesting applications that I've seen is simulations for new chemistries and new kind of material sciences.
Yes.
So that if you're let's say for example you're General Electric, right? And you're designing a new wind turbine. Well, the resistance of the material that you're using has a huge impact on the viability and potential profitability of your assets, right? So can you figure out a way to make the design, the actual material itself, more or less porous, more or less resistant to wind, more or less resistant to heat, more or less malleable? All of these different things that because of with the new computing, you can actually, you've kind of broken the barrier a little bit that would have otherwise constrained you, right? So you're able to test and to play with different permutations and potentially get to a much better place.
Yeah, so considering the wind turbines, you can even do a complete analysis of the location of those wind turbines, I don't know, in an ever-changing weather system on a certain place in the Netherlands or anything. So that would be like, even 10 years ago, that would be really hard because the data was not there on that level. And we couldn't compute it at that moment. So even the modeling is getting also there. So in every physical, let's say, turning world, if it's really small, like proteins or really big, like wind turbines, you can test everything.
Yeah.
I think another great example, I think NVIDIA published this 2 weeks ago,
Yeah.
that they're using an AI to design carbon storage wells. And they say they make it 700,000 times faster. So they go from designing a well in 2 years to 2.8 seconds.
Yeah,
It's really cool.
Yeah. And this is the beginning, huh? It's
there's a wonderful example that we have in our portfolio that's sort of similar to that. It's a company called Aurora Solar. And Aurora takes LiDAR data worldwide, right, to be able to map out rooftops. And so they're able to work with rooftop installers and design the optimal layout for a rooftop residential solar system without ever having to go to the home, without ever having to go climb the roof, without ever having to take out the measuring tape and do all the things that you would have otherwise had to do in a very manual, very repetitive, actually very kind of risky sort of process, right? They're able to do that entirely remotely with a fraction of the time. It takes something that would have otherwise taken weeks, now 5 to 10 minutes to be able to design and then play with the actual array so that you're able to integrate the best layout with the right amount of, or with the right type of hardware, with the right, you're able to get the whole thing basically, automatically designed.
I'm really curious on the application of AI, for example, for really hard problems, such as nuclear fusion. I mean, there have been companies trying to crack nuclear fusion for the past 50, possibly even a longer amount of time, 50 years or longer. To what extent do you feel artificial intelligence and sort of like the ability to run, massively bigger calculations at a much faster speed? To what extent do you feel that will accelerate sort of really hard technologies such as nuclear fusion and sort of like the possibility of these, of this becoming a real solution to climate change within the foreseeable future?
So one application I've seen, I think both of our guests are still thinking, is that actually AI is really helpful in selecting the most promising next experiments. So you can give it the results of all the experiments you've done, and it will give you a suggestion for which experiments will give you the most progress.
Yeah, so I think it's like speeding up the whole experimental design. So you have like multiple options. So if you go to CERN in Switzerland, it's still like finding the needle in the haystack. So that whole like tunneling to that needle, that will go faster and faster. Yeah. So actually that's what we are doing, but it's really hard to predict how fast that will go, because it's still a needle. Yeah.
Yeah, and I would maybe add to that. What's held us back isn't necessarily the compute. I think there's a lot of capital that's also required for these types of deployments, right? So it might help accelerate us finding that needle, like you said, but that's just going to be one of the many things that's required to actually get it to break through.
Juan,
Yeah.
I'd love to hear from you, kind of what applications of AI in climate would you love to see, but you haven't really seen yet?
Good question.
Ideas.
We're seeing more and more each day. So I'm not sure that there's a lot of things that we haven't seen, but I think that there's a couple of things that we would love to see more of. I would love to see more of. I talked about some of those workflow automation platforms. I think that the reason those are exciting is that they're useful today, right? You're able to get to something to market very quickly. You're able to solve a real problem today. And I'd love to see more entrepreneurs thinking about how to solve real problems with great technology, but using real sort of following real problems. That's number one. I think that there's some interesting applications around global data. Climate is a global sort of problem and phenomenon. With the lowered costs of, for example, satellite launches and these types of much broader scale data inputs that we're able to have. I think there's a lot of potential use cases to be able to measure things like forest health, to be able to measure things like water, to be able to measure things like resource health for the planet that I haven't seen a ton of really great technology in. And then I think the third kind of big category is when you're thinking about renewables penetration into the systems, right? The more renewables that we have on the grid, the more sort of balanced or flexible load that we have, it kind of complicates the system, right? Can we use more and more AI tools to help balance things out, to help us get to, again, like better outcomes without necessarily needing to think about turning the thermostat down? Because humans don't think that way, right? But if you can make some of those choices, quote unquote, make some of those decisions be automated to get to a better kind of ending point by maybe taking the human out of the loop a little bit behaviorally, I think that you can have a pretty big impact.
Yeah, cool. Juan, just to move on to investing in climate, artificial intelligence solutions. Suddenly, everything is an AI company. I think we're starting to see a little bit of bubble formation, which might remind us of the .com era. We'll have a lot of .ai domains, I guess, in the coming years. How do you cut through the noise? I mean, how do you evaluate what is legitimate and what is, a defensible application of artificial intelligence versus what is not?
Yeah, that's a great question. We have a rubric at Energize that we use for all investments, not just AI investments, but we're looking for the product. Obviously, how defensible is it? Is there a real technical moat? Can we build something that is scalable? We look at markets. So, how competitive is the market? How much real budget availability is there? What is our view for potential growth and penetration? We look at the economics of a particular company. So for us, it's very important that companies have real traction, that is, a real sort of positive gross margin trajectory to potentially, end at profitability. We look at the team. Does this team have something that's special and unique? Or are they more tourist in the space? And we've seen a lot of that recently. I'm all for more and more talent coming in and people that are curious about solving these types of technology problems. But if you're a tourist, it shows. This is a really tough space to play in, right? It's not gonna be super easy for the person that was doing Web3 crypto something and all of a sudden just decided to go to climate because it's the next biggest hottest thing. And so you're able to test that out, with people. obviously. From a technical perspective, we rely a lot on that customer journey, right? That customer validation. Customers do much better product technology sort of testing than a lot of investors that I know.
Yeah, cool. And
Yeah.
Bastian, you also are an angel investor. Have you
Yeah.
invested in AI companies, and how do you sort of test the quality of what they're building?
Yeah, so we also do like early stage from engines, help a lot of VCs with like, okay, is this an AI solution which actually helps solving the problem? So I think it starts with the founders. Are they coming into the space to solve a problem? So that's what we already discussed. So that's the first. So you can check if they are really like committed to solve that problem. And then you can check, is it scalable? And that's actually quite easy, because then again, okay, is the data available to make a proper model? And is the infrastructure and the human assets in that company also available to, if you have like multiple clients, to also move on and scale that company? And what I see a lot is that the problem is sometimes there, even the founder really wants to solve that problem, but he didn't solve, he also makes a really good prognosis of his sales, but he never thought about technical scaling of the company. So that's the technical AI problem behind it. So you can check it. Yeah, okay, is your real asset of your company in the data or in the model or in the infrastructure? So what are you adding? Because of course, with ChatGPT coming, we see that we are building on, well, the shoulder of really big giants at the moment, and they all fall off. So I think you really have to dive into the technical scalability of things, connecting that to the problem. So I invested, I think 2 years ago, and that's also the answer on the previous question, what do we have to do more? We tend to do a lot what we can see. So now we have satellites on the Earth, but we cannot see in the ocean a lot, and we cannot see underground a lot. So I would opt more for data in the ocean and in the Earth. So I like the NVIDIA thing as well. So in the ocean, I invested in a company called Plan Blue, and they are actually mapping the whole ocean floor, which can be used for coastal infrastructures, but also used for seagrass, which is also really good for capturing carbon and storage there. And that's all about the data, because, well, we go to Mars, but we don't know about around 65% of our own planet. And we can collect that data first, and then we can solve a lot of problems, because climate is also in the ocean.
Absolutely.
Yeah.
One follow-up question from one of our listeners, David Miller, is what creates technical moat in this space? Bastian or Juan?
I think there's three things. I think it's data. I think it's differentiated access to differentiated data.
Mm-hmm.
I think it's context, so differentiated context about what that data is or isn't supposed to be doing. And I think that it's that those two things together lead to a compounding advantage. And if you can get all three of those things, then you have a better shot at having a technical moat.
Just to understand differentiated context, can you explain that a little bit more?
Sure. So think about going back to that wind turbine example.
Yeah.
Right? There are subject matter experts in vibrations and tribology for wind turbines that know exactly what's supposed to happen, right? Can you take that and codify it so that that's part of the sort of training, I guess, of the model, right? That's not something that you or I could do off of the street.
Yeah.
Right? You'd need to have some sort of differentiated context, some sort of subject matter expertise that makes that data valuable.
Yes. All right. Wonderful. Cool.
Yeah. So this is a really good example, because there's like enormous amount of data on the wind turbine.
Yeah.
And this guy or girl can only watch to a certain amount of data or annotate that or check if it's valuable, yes or no. So you have to have a mechanism that you can increase that feedback
exactly.
on that model.
And to what extent are companies that are building solutions in this space typically building, as you said, sort of on the top of the shoulders of giants? Are they building on top of ChatGPT, or are companies typically building their own sort of large language models? And how important is that from an investor point of view? Do you care whether they're building on top of ChatGPT or building their own model?
I think it depends, honestly. is the right answer. If you go away from ChatGPT for a second and think about Amazon, AWS, or Salesforce even, right? Like we have the companies use that to, right? You're not asking startups to build their own data centers. So if you can, optimize for that, then I think that's okay, because that is not what should be your defining advantage, right? If your defining advantage is meant to be compute or cloud or whatever, then sure, you should have that in-house, right? But if it's not, and you're just using it as part of your tech stack, then it should be the opposite. You should leverage, the best available tool to help you, develop faster and bring your product to market.
Yeah, exactly.
Yeah, I completely agree. So the essence of the company has to be on the balance sheets. You have to know what you're doing there. But if that's not the asset, you can build on the shoulders of giants. Why not?
Exactly.
And Bastiaan, what type of companies does Engine support? Is it more of the former or the latter?
Yeah, both. So we got a lot of questions now. Can you build an LLM for us knowledge? Because we have a lot of knowledge and we want to own that knowledge. So can you build like a large language model on that? So they are trying to get that asset in, and we can help them with accelerate that. But we also see a lot of startups and scale-ups who needed help because they build on top of, well, ChatGPT or something different. And they need more help in the feedback. So are we going in the right direction? So they made a first version of the model and they try to audit that and, okay, what will be the next step? And how can we put that in an infrastructure that model, which is changing over time, can continuously be checked and improved? Because we all think that we create a model and then it's finished, but it's never finished because it's just the simplifying of reality. So reality is changing. So the simplifying reality is always changing. And so it's a never ending story.
Yeah. Quick question on sort of the valuation side of things. Juan, we've seen sort of a downturn in the general public and private equity markets, and a lot of companies are having difficulty fundraising. What are you seeing specifically within the AI software or climate AI software space? How hard or easy is it for these companies to raise funding, and what are you seeing in terms of valuations?
Yeah. First of all, it's never easy to fundraise, right? Like you have to, it's always hard to do that, even in very hot markets. But, you're totally right. The markets have retrenched significantly in the last, call it 12, 18 months from where we were before. There have been a couple of pockets that have been more resilient and that have attracted more and more investor demand and more interest, and therefore valuations have been well supported. And those two pockets independently have been AI and separately climate. You put those two things together and you get kind of a compounding effect from a valuation perspective. And so we have seen very high prices paid for companies. That is, number one, I think that's exciting in some capacity. I also think it's very nerve-wracking because that's not what you should be optimizing for. Right? You should be optimizing for building the right company and solving the right problem and being able to capitalize it effectively for the long run. And I think that we're going to see that correct in some fraction of time.
Yeah, it's so important to be wary of hype and hype cycles and super high valuations.
But it was changing fast because I raised like 2 years ago and then a year ago, and it was completely different conversations with a lot of early stage investors, especially because like the sentence like AI is becoming a commodity was like 2 or 3 years ago was like, Bastiaan, a commodity, we're just starting. And now that sentence is, yeah, okay, well, what are you going to do? So you see a bit of a shifting, which is of course because we all talk about it, but you see that also in the investing climate, being a founder, especially raising money, which is still hard. That's correct.
Exactly.
So Bastiaan, Juan, so far we've mostly been talking about the good sides and what AI can do to help us get better at solving climate change. Obviously, AI is also very energy intensive and computational intensive. Would you say on balance, it's a net positive or a net negative for the transition?
I think it depends. It's a tool. How do you use the tool is up to us. I think that I think our world, our lives are going to be more energy intensive in 3 years and in 10 years and in 30 years, and that is going to continue to accelerate. I think in general, that is true. And I think that the merits of a technology are not necessarily felt just on that. I think that if we can use this type of tool to help us design a better system, it should be a net positive.
Yeah.
What are the best ways you've seen to manage this increase in energy intensity, or how can we make sure that we manage this energy hunger of AI?
Well, the economist in me says, price it.
Yeah.
Yes.
Price it. I mean, ChatGPT is free, right?
Yeah, there should be a carbon tax
because it's
on data usage.
Because it's still early, so we have to collect more and more data. So that's the whole thing. So we are using. So we get back to the point we already make. If we all use it for a problem which we solve, we can calculate it in the cost of the problem what we are solving, and then we are net positive. But we are using. Well, spent 20 years building a lot of models. I did it myself. I built a lot of models where you never used. Well, that will be not net positive. So we really have to be critical about, okay, what are we solving here? And do we take that cost in the equation of solving that same problem? So it's part of the transaction costs. And that's not really what everyone is doing at the moment. So, and I think that's also part of the hype. So that part is really a hype because we all want to try it. But maybe we are just of that curve and it will go down and we tend to use it for only really useful stuff. But well, mankind is not really good in that.
Yeah. And Bastiaan, speaking of risks, AI is quite a black box. When you ask ChatGPT a question, you get a pretty reasonably sounding answer, is my experience. But how do you know what is true, and how do we ensure that, you know, information that we get through AI is correct, that it's sort of cannot be infiltrated by bad actors? How do we deal with that black box nature of AI?
Yeah, so that's actually the purpose of Deploy. So after spending a lot of modeling, I was like, okay, but this cannot be true. Like, especially for high impact decisions, like on your bank loan or on your surgery, you have to be able to explain to a certain extent what is happening there. If we're going to build explainers for like really extensive neural network modeling, then we will never be net positive because it will be more costly to build the explainer than a model. So that is not a way to go. So I think it's three things. The maker of the model has to be what I call human-centric design. So it has to be being used by a human. That would be always the case. So then you specify already how you create a model and how a certain person who wants to work with the outcome can give feedback to that model and can interact with that model. And the other one is basically logging everything you can do, and you can make it reproducible. So I think that we are now also with new laws in Europe coming up, that we tend to have an agreement on that. So you have to be able to explain in hindsight why you make a certain decision on someone's life or someone's loan or whatever. I think it's the same with climate. We can make really good holistic models about, I don't know, natural disaster or severe weather conditions. But well, we see now in the Netherlands more code alarms about weather, but if they're wrong, there will be damage. If they're like false positive and false negative, is both not what we want. So we need some kind of reproducibility, explainability, and an expert in the loop to solve that. So that's part of the infrastructure. So it has to be, before you start modeling, you have to be aware of those three things. Probably it also helps you with structuring your problem. So what am I actually solving? And that could also enhance, like, okay, we don't have to do this. So we don't need all the, well, electricity and stuff which is involved.
We have one audience question, speaking of regulation, and the question reads like this: what are your thoughts on the draft AI Act seeking to regulate artificial intelligence within the EU and prohibit AI that exploits vulnerabilities? They have thoughts on to what extent that draft legislation can sort of like slow down the development of artificial intelligence versus sort of the aim of keeping it safe.
I'm not very familiar with the European regulation as a US-based investor, so I feel unqualified to answer this question. But I will tell you from a more personal point of view,
Yeah.
I think some guardrails are important with technology.
Yeah.
And I don't know if that should take the shape of regulation or peer groups or open source, communities, or I mean, in an ideal world, you would have the customers. But I do think that some guardrails are going to be important.
Half a year ago,
So actually, so I want to react on that. I think really important that you say like even the customer. So I'm not fond of like over-regulating stuff, but the end user of what's going to use the AI or the decision or the problem, they have to have some kind of feedback on that mechanism. So if a manual decision was made here in Amsterdam on that I didn't park my car right, I want to have feedback on that. So if AI is taking over, I need to have feedback. So probably we need some regulation, because otherwise all customers will have in their way some kind of feedback, and it gets a little bit, well, messy, but it's about reproducing results and about getting feedback on that model. That are the most important things. They are both also in the European AI Act, but will take ages before we already will suffer from that law.
Unless we get ChatGPT to write the regulation, I think probably it could do a pretty good job at that. Quick question. Half a year ago or a few months ago, there was a big discussion amongst a lot of tech leaders, including, for example, Sam Altman from OpenAI, on whether there should be a pause on the development of generative AI. What's your stance, Bastiaan?
Yeah, for me, it's quite easy. I never saw anything in the world that pauses to improve. So of course it gives us maybe more time to think about what we are doing, because things are speeding up, but things are speeding up for the last 20 years. So nobody was talking about regulation when the first chess computer won from Kasparov, which was also a main thing in AI. Or we all watched AlphaGo because we think it's funny on Netflix, but nobody read the article, I don't know, 4 years ago about what is called self-attention in transformers, because that's actually what ChatGPT brings to life. So I think it's really good that it creates the discussion. So we've been in a discussion here with lawyers, technologists, all kinds of different stakeholders, and I like the discussion. I don't like the pause, but the pause helps for the discussion. So if that's the reason to get into this discussion and that we are talking about it, then I'm fine with being paused, but we're not actually pausing, and nobody is pausing.
And Bastiaan, have you seen anything in the development or the applications of AI that scare you? Like, is there a reason to pause?
Well, not in ChatGPT. It's not really scaring. What's scaring is because it comes really close. It's the human task, which is, so Jacqueline is doing a lot of ChatGPT probably because it helps her, and you're all doing that because it helps her in your day-to-day work. So it's mainstream. So if you're not a chess player, you didn't care about Deep Blue. So I think that's the big difference. I'm more scared about, I don't know, you have OpenAI Dectail, I think it's called. So you can watch it, a human, and a robotic can learn everything what it watches. So I think that's more scary, because from a perspective, you can learn every task that a human is doing with rapping physically, but also warfare or whatever. So if you think in that way, it's for me more scary than ChatGPT. So it's if it's again used for things which I find scary, then AI is also scary.
Yeah, cool.
There's maybe two things to add. I talked at the outset about how our view is that the energy transition is going to be more decarbonized, more decentralized, and more digital, and so there's more use for software to help improve. Software can also create a lot of damage, right? Cybersecurity and more adversarial types of deployments can be a real threat to, I think, to our society and certainly to our energy systems. And this is a tool. It's going to get sharper. How you use it will matter a lot. And I think that is a big risk that we see as a system. And then maybe another different kind of risk, but I'm sure you guys remember when you were young, maybe you had a parent that said, oh, you shouldn't use your calculator because you're not going to learn how to do math or something like this, right? You shouldn't rely on Google because you're not going to be able to think critically. I worry about our relationship with that technology and people that come up with it in a native way, the kids of today and tomorrow, how they're going to use that. Will it erode? Will having this experience of being able to quote unquote talk to a computer the way that, ChatGPT kind of feels intelligent, right? Will that erode our ability to think more critically? Will that erode our powers of creativity? Will that erode, some of the things that actually make our intelligence uniquely human?
Yeah.
I don't know. I think that's an interesting question.
Good way to end this webinar. Bastiaan and Juan, thank you very much. Maybe one final question. What is the #1 resource you recommend that people read, listen, watch to learn more about AI? Bastiaan.
Oh, that's difficult. There's a good book called The Alignment Problem. So again, the word problem.
Yeah.
And it helps you getting the problem correctly to the correct tool, which is a lot AI, because everything is AI now. So I recommend reading that book.
The Alignment Problem. Cool. Juan.
I think that the MIT has a bunch of different courses out there that you can learn from a more technical perspective. I would recommend that you guys check that out. MIT, Berkeley also has some similar ones, but just be driven by your curiosity. I think is the big one.
Thank you so much, Bastiaan. Thank you, Juan. Thank you all for listening and hanging in there. And I hope to see you in a future webinar. Thank you all.
Thank you.